Today we are diving into one of the building blocks of many video games, Combat AI. In this video I will show you how I designed and implemented my own system. Hi guys, I'm Jimbo and welcome back to another devlog where I show you the progress of my indie game. Before creating the actual Combat AI, I implemented a simple final state machine like the one used for the player, with the idle and chase states. In the first state, the enemy is just standing and waiting. In the future, I'll replace it with a wander state. Instead, in the chase state, the enemy starts to follow the player using a navmesh system. After that, I started thinking about how I could design the combat AI and what are the behaviors I wanted for my enemies. I came up with these 5. Move around the player, moving towards the player, attack, block, roll. At first, I tried to implement the AI as a behavior tree, but it was not really what I was looking for. Instead, I created a combat state that has a specialized final state machine inside it with all the necessary states. This final state machine has a configuration file that can be used to create a different type of AIs. The enemy's decision process works like this. It has a list of as many situations we need. In this case, I designed 2 of them, the not close and the close. Every situation can have multiple actions. In the not close one, I added 2 actions, the move around target and the move towards target. For each action, you can specify the percentage for which that action can happen. So if you want a more aggressive and intense combat, you can have a higher percentage on the move towards target action, so the enemy will go straight onto the player more often. For the close situation instead, I have 3 actions, attack, block and roll. As for the first situation, you can play with the percentages to create a specific behavior, like a more defensive one, incrementing the block action and the roll action percentages. These actions are gonna be played once the enemy will be close enough to the player. I think this system is flexible enough for now, because I can create different enemy AIs just by creating different config scriptable objects and setting the various situations with its actions and percentages. What do you think about it? Let me know if you have designed Combat AI before and how have you done it. In the second part of this video, we will talk about entity stats, blocking system, and also, as some of you have requested, how I implemented the attack system. In my game, I introduced the entity stats, health and stamina for now. The player has a simple UI in the top left corner of the screen with 2 stat bars. Instead, each enemy has its own health bar. This bar will appear once the enemy has noticed us and instead will disappear once the enemy will turn back to idle state or will die. Talking about the stamina system, each state has a stamina cost and it will be checked before you can perform a specific action. At the moment, the actions that can consume stamina are attack, roll, and when you block an attack. The stamina continues to regenerate over time. I think that in the future I will need a system where if you don't consume stamina for a specific amount of time, it will fully regenerate instantly, like many other games do. Other random things I have added to my game are a death state for the enemies, basic hit effects, and as I said before, a blocking system. For the last one, an entity can block an attack when it's in idle or move state. The blocking system will check that the hit direction is inside a specific field of view, so if another entity attacks from behind, it will not be able to block the attack. Last topic, the attack system. As you already know, I'm using a finite state machine to control the entities. Inside this finite state machine, I have an attack state. This state functions in this way. On enter, we take the attack set scriptable object that we get from the weapon we are holding. From this attack set, we can get the sequence of attacks this weapon has. We take the attack based on a attacks counter variable that we use to save how many attacks in a row we are doing, so we can progress in the sequence, selecting the next one by incrementing this value. From the selected attack, we can get some necessary variables. The force of the movement when we perform the attack, the percentage of the animation clip in which the movement should start, and the start and end time percentages in which we need to enable and disable the weapon hitbox. At this point, we create a timer. The length of the timer will be the attack animation length. When the timer will surpass the specified percentages, the move and the enable-disable hitbox functions will be called. To have sequential attacks, as I said before, we will need to increment the attacks counter variable, when, on the state change function, the next state we get is again an attack state. This is basically the logic of how it works. Talking about the animations, each attack object has an ID. This ID will be set in a variable in the animator. Inside the animator we have a blend tree for the attack animations only, where for each attack animation there is a specified value, the ID we set through code. This is the most flexible solution that came to my mind. Do you have a better one? Or can you see what problems could I have in the future? Let me know in the comments. That wraps up today's devlog. Thanks for joining me and be sure to stay tuned for the next episode. Bye.